Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. So in this video, I will explain the last topic in magnetostatic, and we call it as a magnetic energy. Alright, in electrostatic, so we come across to a topic that what we call it, the name of the topic is electrostatic potential energy. So, and that particular energy, so we calculate how much energy that we inject inside the capacitor, okay, in order to store energy inside that particular capacitor. So in this topic, so we will learn about magnetic energy. And the magnetic energy is defined as energy stored by an inductor, so due to a current. So basically, when we have an inductor, and then we inject some value of the current inside the inductor, so the current will be increased from 0 until certain value of final current. And the relationship between voltage and the current of the inductor is given by this expression. So we have V is equal to L di divided by dt, and the unit of it is equal to voltage. So in order to calculate energy, so energy can be calculated by using the expression. So we have Wm, which is, this is the magnetic energy, integration of P dt. So this is the power and this is the time. And the unit of it is equal to joule. As we know, the expression of the power is given by this expression, is equal to IV. So because of that, so the energy can be calculated so by using this formula, which is integration of IV dt. By referring to this expression, so we will have we can rewrite this expression become this. So we have V dt is equal to L di. And by replacing inside this expression, then we will have the magnetic energy is equal to L integration of I from 0 until I. So this is the final value for the current inside each inductance, I dl. So by solving this mathematical expression, so we will have the magnetic energy can be represented by this expression, which is half Li squared, and the unit of it is joule. Okay, as what we have been derived in previous chapter, which is inductor chapter, so we will have the expression for inductor is given by this expression. So we have mu n squared S divided by L, and by replacing this expression inside this equation, then we will have the magnetic energy is equal to half mu n squared S divided by L, and the value of I is given by this expression, okay, BL divided by mu n squared. So the expression of the current can be defined by using this formula. So this is the formula that we get with the same topic, which is the same in the topic of inductor. So whereas the expression for the magnetic flux density can be write as this expression. So mu n I, so divided by L. And if we rewrite this expression, then we will have I is equal to BL, so divided by mu n. And by replacing this expression inside this equation, then we will have this expression. Then by solving this expression, then we will have the magnetic energy expression can be represented by this expression. We have half B squared divided by mu and multiply by Ls. So this Ls is equal to volume expression for a solenoid. Okay, so because of that, so we can rewrite again our expression for the magnetic energy is equal to half mu h squared. Okay, so this expression come from this expression. Okay, so we have B is equal to mu h, then we will have h is equal to b divided by mu. Alright, so we will have mu h squared multiplied by V, and V is the volume for the solenoid or for the inductor. So if we look into the magnetic energy density, okay, which is the magnetic energy here, so divided by the volume of the inductor, so we will have, so Wm, so divided by V, and is equal to half mu h squared, and the unit of it is equal to joule per meter cubic. So based on this expression, we just cancel out the expression for the V. Okay, so with respect to the variation of the volume, okay, so let's say the volume for inductors, if the volume for the inductor is changed, so we can find the total magnetic energy inside any particular inductor with given certain value of volume is equal to half volume integration mu h squared multiplied by dV, and the unit of it is equal to J, or joule. Alright, so this is the last topic and the shortest topic for this particular chapter, okay, which is the chapter of magnetostatic. Alright, so that's all. So should you have any problem or question, so please do not hesitate to submit to me. Alright, so that's all. Thank you and have a nice day.